This did save. All right. Where was I?
As far as I could tell, we were trying to combine that C file with the results of grep.
Yeah, I mean, I was in the middle of trying to explain something to Trevor. I don't remember what. Oh, why expressions are backwards sometimes.
Yeah, how it's different. The literal and special characters are different for each language.
Correct. Yeah, that's the best way of putting it. And so the same thing for the sed command, the sed. It works just like grep in how it treats things, because it's looking for, that means or. In bash, that means pipe. And so it's different. All right, so this command works. It gives us our 6 that we want right there. And the head command works. It gives us the first 6 rows of that. So now we just need to do what to squeeze them together? We just did it for question number 1.
So just paste.
Okay, we just need to paste the output of head 6 c.text and the output of this. Now, don't get freaked out, but this is something your chapter covered and we're definitely going to be using a lot. Starts with B or starts with E. Okay, what happened? I took those 2 commands that we had that we knew were giving us good, happy answers. I put them inside of parentheses with a little redirect facing left.
So that the less than symbol puts it to the standard in.
It does. Well, it becomes something that it didn't used to be. This is called process substitution. And technically what's happening is that this is an anonymous pipe that can be used in any direction. So it doesn't have to go to the thing on the right. This process substitution means that anything inside of here gets evaluated first and then becomes its value. And so in this case, head 6 c.txt is just these first 2 columns. And we're pasting that with the output of this command, which was those 6 rows.
Do we need to give it a file name, though?
We gave it words.txt inside, yeah. Is that what you meant?
Like, so if we wanted all 3 columns in like a new file, would we?
Oh, yeah, then we could just redirect as normal to a new file. I'll call it d.txt. And there's D. So there's kind of a lot going on here. Let's try maybe a simpler example. So if we say echo 1 and 2 and 3. Oh wait. See how annoying this is? Not even going to work for me. Echo 1, 2, 3. We'll just do that. And echo 4, 5, 6. If I were to say paste echo 1, 2, 3 and echo 4, 5, 6, it pastes the two outputs of those things together. These anonymous pipes, these command or process substitutions, are treated as if they were like a little temporary file, almost. Okay, so just like our redirect pointing to the right sends it to a new file that we name, here it's called anonymous because it's just a temporary file that's not even written to your storage, so it's really fast. You can do this with really big files. And it's done through streaming, so it can be done with gigabytes of data. It's an anonymous temporary file in essence. And so when paste sees these, it looks at this command, evaluates it, finds the output, and treats it as if that was a file. Same for that one. And so then we're just pasting the contents of those two pretend files together. So again, this is process substitution, and it's real handy. So that was number 2. So already we're dealing with, where was that? It's kind of a big looking command, but really it's just paste, head, and grep with process substitution. Okay, so you could have, I've actually had to use this exact formula trying to make a new DNA database that was given to me in a very weird format. I wanted to find things that began with this pattern and basically make them into a tabular format. And it was just that simple. One little line of instructions. Okay. You've got to have questions about this process substitution.
I do. So you mentioned you can put files in it.
It is technically a file. This whole little bit right there is technically a file. It's just called an anonymous pipe, and it's pointing it to like a temporary file that lives in your terminal that's not named. I don't know if that makes things worse.
Could you inside of the parentheses put a pre-existing file? Like I see that you have c.txt, but like can it just be like you mentioned really large files? So if I have like a FASTQ or something file, like
right. So I mean, if you just want to put a file that exists that you don't want to change at all, you don't need the parentheses because that file already exists. I could just say paste c.txt and the value of grep I starts with B or E, word subtext. And
Okay.
you see the output there. It's giving me the entirety of the first two columns, because that's what c.txt is.
Right. So only if you're running some sort of command on the file is it necessary?
Correct.
Okay.
And so it did paste these together, but it ran out of things to paste in the third column. So just put nothing there.
All right, so within those parentheses, you can add whatever you'd like. So you could add other commands piped
Yeah,
together.
and you can even have a chain of commands, like a bunch of pipes. So let's see.
Yeah.
Let's say sort c.txt. No, let's cut it.
6.
Cut with the delimiter being a tab, another special character. Field 2, c.txt. Pipe that to sort. What didn't it like? Must be a single character. Did those get entered as white space, maybe? Yeah, interesting. Okay, so those weren't separated by tabs, they were separated by spaces. But there you can see that we've cut it based on spaces, taken the second field, and then sorted it, and then pasted it in. We could also add another pipe inside of the parentheses here. That's sort. And so it's sorted alphabetically in the third column as well. And so you can just chain whatever you want. It will evaluate whatever is inside of this parentheses, and then it'll put that as the input to whatever command you're using. So for here, paste, you give it some file names. That's what it really wants. And so it's taking that and treating it as if it was a real file with a name. It's just kind of evaluating it first. All right. We got a few minutes. We can do number 3. Return the first 6 sentences from story.txt. So let's say cat story. How are we going to do this? Plain English. What's our one possible approach?
Break it up by periods.
Okay. How do we do that?
I'm guessing with sed.
Okay, so sed streaming editor, so we can edit things.
You can use it to
So
edit.
that's a possibility.
Right?
So let's see. Sed, and what's our formula? We're gonna search for, what are we searching for? Period. And we're gonna replace it with, what should we replace it with?
Maybe an enter, so it's a new line.
New line is written like that.
Oh, okay.
And we're going to do that to the whole thing. Let's just see what we get there. Whoa. Whoa, whoa, whoa. Well, that didn't quite work, did it?
No.
Man, we're so close.
What did you get? Like, what is that output?
a period is a special character. It means
Oh, yeah.
one of anything, remember? It's just like the asterisk. So let's say literally a period, replace it with a new line. What it did was it took every character and changed it into a new line.
All
And
right.
so that
Yeah.
was our output.
Oh, okay.
Okay, so that's a bit better. So this command here, we split this up. Every time there's a period, we change that into a new line. I don't like that it's leaving spaces at the beginning of some of these.
Mhm.
So let's say look for a literal period and then a space. That's a bit nicer. All right, and that left our last period because it didn't have a space after it. Then how do I pick the first 6?
Just pipe it to head, like head 6, right?
Sure. There we go. It's different than what I've got here. I didn't put them all on new lines, but it'll work. That'll work. Let's see. If we wanted it all on a new line, we could change period space not into a new line, but a single character, like an underscore, something that's not really turning up in our story. So let's see. So every time we see an underscore, that means there used to be a period and then a space.
Mhm.
And then maybe we could cut, and our delimiter could be an underscore. And we could choose the fields 1, 2, 3, 4, 5, 6.
Hmm.
Well, there they are. And then we could just add another pipe where we do kind of a search and replace thing.
Yeah, restore the periods.
Searching for underscore, replacing with period space to all of those. Okay. So I believe that's what I actually had here. Yep. So either one of those finished the prompt, which was get the first 6 sentences. What I'm hoping you're starting to see is that this is actually training for real life bioinformatics stuff, even though it's just a couple paragraphs from the BFG. You got to look inside your files, see how they're formatted, and then use that as your plan of attack. So in this case, sentences, well, that means period. Hopefully period space if they typed this all right. Okay, so we can use that to our advantage. Between grep, sed, cut, paste, we're already being able to manipulate huge text files. Right. This obviously is not a biological example, but all bioinformatics data is text-based, and it works on stuff like this. Okay. Let's see. Yeah. What is this going to return to us? This works similarly to the process substitution, but instead of the little less than pointer, it's a $, meaning the value of.
So just a number. That's all it should return, right?
Yep. So there are 6 files in this directory. That's my output because I said hey, this is a variable I want you to do the value of. Okay. How about this one?
It should return 5 lines saying like this is line whatever number it's on, right? So like 1 through 5.
Yep. With a little period. Yep.
How does it know to do, like, for I in 1 through 5? Like, how does it, like, is this command just automatically looks for lines? Like,
Oh,
how
this
is it
is-
not looking for characters rather than lines?
It is looking for characters. So this is your classic for loop. If you haven't already, watch the video on our resources on how to do for loops. It's for some variable name. It can be var. A lot of times you'll see foo as a variable, your mom, and then you give it some set. In this case, it's just the numbers 1 through 5, and that's how you write them. Or you could give it a bunch of files. Do echo, then the value of your mom, done. So each time through the loop, it's changing the value of the variable that you set as it goes through the loops. So we could echo your mom, then we could head 1, the value of your mom, done. So we can add as many steps in our for loop as we want. It's giving us the value of your mom, and then it's giving us the first line of it. And then this is all on one line. Okay. We're out of time. For your practice, try to get number 4 here. If you can get number 4, you're doing good. You're in good shape with process substitution, grep, and sed. Remember what you've learned about special characters. We've learned new line. This is tab. This means literally a dot. I think it's R. That's for Windows type file endings. It means carriage return, like a typewriter. If you want to actually include a star in your output, you have to do \star. So just keep those in mind. Play with it, and I bet you can get this one, knowing what you now know. All right. Any last minute questions? Your assignments for next week? Nothing. We'll do it together. We're doing our first case study next week. Make sure that you've read all the chapters up through where we are now, because you're going to need them for sure. All right, I'll see you on Tuesday.
Sounds good. Thanks.
Yep.